Hello everyone, welcome to our channel Off Campus. Before going into the video, kindly subscribe our channel Off Campus and then click on the bell icon. Then only you will receive notification whenever we upload videos. In this lecture, we are going to see problems in signals and system. These problems are taken based on the exams like competitive exams like tneb assistant engineering and trb polytechnic engineering. These are the most frequently asked questions in the gate exams also. These all the questions taken based on the competitive exams. Okay, these are the repeated questions in signals and system. We'll see one by one in this lecture. Okay, what is the first question? The response of an initially relaxed linear constant parameter network to a unit impulse applied at t equal to 0 is 4 e power minus 2t into u of t. The response of this network to a unit step function will be, what we need to do? We need to find out the response of the network unit step function. We need to find out the step response. Okay, the response of the step function means step function. What is given in the question? Impulse response is given. Impulse is applied at t equal to, first read the question carefully, what is given and what we need to find out, all that. Okay, we need to find out the step response for the given function. What function is given? Impulse response is given. So from that impulse response we need to find out the step response. So what is this impulse response? H of t equal to 4 e power minus 2t into u of t. This is the impulse response. So we need to find out the step response. Okay, step response. How can we find the step response from impulse response? It is nothing but minus infinity is general formula. Step response equal to minus infinity to t impulse response with respect to dt, with respect to time. So step response, how to find out the step response from impulse response is nothing but just integrate the impulse response over the limit minus infinity to t with respect to time. We can get the step response of the value. So impulse response is given as 4 e power minus 2t into u of t. U of t, what is the function? U of t is a unit step sequence. What is that? U of t equal to 1 for t greater than or equal to 0 and 0 otherwise t less than 0. Okay, this is the function of u of t. So it varies up to, u of t will be 1 for 0 to infinity. Okay, so then the limit in general it is minus infinity to t, but what is given? U of t 4 e power minus 2t into u of t. So limit gets changed 0 to t. Okay, 0 to t. So 4 e power minus e power minus 2t dt. So 4 is a constant taken outside. When we integrating this, what we will get? E power minus 2t divided by minus 2. Limits varies from 0 to t. So 4 minus cancel this minus 2 na, minus 2, then apply the limit. Instead of, in place of t, so just substitute t. So e power minus 2t minus, applying the lower limit, e power 0. In place of t, just apply the limit 0. So e power 2 into 0, we will get 0 only. So e power 0. So it is minus 2 is outside. So multiply by minus sign, we will get e power 0 minus e power minus 2t. E power 0 value is nothing but 1. So 2 into 1 minus, this will be same, e power minus 2t into u of t. This is the step response s of t. So s of t is nothing but 2 into 1 minus e power minus 2t into u of t. Option A is the right option. We'll move on to the next problem. What is that? The Z transform of a signal is given by C of Z equal to 1 into, this is a constant 1 into Z power minus 1. Some function is given, C of Z. What we need to find out? Its final values. We need to find out the final value for the given function. So just write down the function. So when it is multiplied by 1, we will get the same value only. So just ignore the 1. Z power minus 1 into 1 minus Z power minus 4 divided by 4 into 1 minus Z power minus 1 the whole square. We need to find out the final value of the given function. It is nothing but Z transform. Final value theorem of Z transform. What is the final value theorem of Z transform? Let limit n tends to infinity, C of n is equal to limit Z tends to 1. This is the basic formula for final value theorem of Z transform. Okay, we need to mug up this, no other shortcut. Okay, limit z tends to 1, z minus 1 into given function. So limit z tends to 1, z minus 1 into c of z. So just substitute this c of z here. Okay, then copy the limit z tends to 1, z minus 1, then we will simplify this value and then substitute 1 instead of z. Okay, in place of z we need to substitute and simplify. Before substituting these, we need to simplify to the some format. Okay, doing some simplification. Okay, take z power minus 1 outside, minus 4 outside from numerator. So z power 4 minus 1, right? Then here z power minus 1 the whole square. So z power minus 2, take z power minus 2 the outside, then we will get z square, sorry, z square, square is in the outside, z minus 1 the whole square, right? It will go to outside. So z minus 1 the whole square. Then we will simplify further by what is that? Minus 1, minus 4, minus 5. This will go to the numerator, minus 5 plus 2, minus 3. So all the z can be simplified by z power minus 3 into z power 4 minus 1. Okay, then 4 into z minus 1. Here also 1 z minus 1. Don't forget to insert this. This is also. So then z minus 1 and the z minus 1 the whole square get cancelled. What we will get? Z power 4 minus 1. This z power 4 will go to the denominator by 4z cube into z minus 1. So there is no negative power, all are the positive power. We have simplified. So now we will substitute 1 in place of z. So just substitute z. What we will get? Or will whenever we substitute we will get 1 minus 1 0. So we need to simplify further. So here no need to go to that z squared minus, sorry, this step is unnecessary. No need to bring it to the denominator. From this step, what is it? Z squared minus 1 a, like this I will write. Z power 4 minus 1 can be written as z squared the whole squared, it is z, right, minus 1 squared can be write like this. This is z squared the whole square minus 1 square. This is like a squared minus b squared. A squared is nothing but z squared. Okay, a squared, a is nothing but z squared. A squared minus b squared, what is that? A plus b into a minus b. So like that, a is nothing but z squared. Now z squared minus 1 into z squared plus 1. So here z power minus 3 also in numerator, in denominator 4 into z minus 1. Okay, then z power minus 3, this is z squared plus 1 squared. Z power minus 3 into can be written as, this is also, see, a squared minus b squared. So a plus b into a minus b. What is a here? A is nothing but z. So z plus 1 into z minus 1, then z squared plus 1, let it be z squared plus 1 in the numerator. What is in the denominator? 4 into z minus 1 in the denominator. Then cancel z minus 1 and z minus 1. What is left out? Z power minus 3, z square plus 1 into z plus 1. Now substitute the value 1 in place of z. So 1 plus 1 2, or this one 1 plus 1 2, this one 1 plus 1 2, 1 power minus 3. Anything power 3 we will get that value only. So 1 power anything. So 1 power minus 3 nothing but 1 by 1 power 3 can be written as, right? So we will get the same. Anything 1 power anything we will get the same one only. So 1, then z squared plus 1, 1 plus 1 2, then z plus 1, 1 plus 1 2 divided by 4 in the denominator. So these and this get cancelled, these will be get cancelled. So we will get 1 as an answer. So the final value of the given function is nothing but 1.0. So 1 is the answer. Okay. Okay, we'll see. The Fourier transform of f of e power minus t u of t is equal to 1 by 1 plus j 2 pi f. The Fourier transform of, therefore, Fourier transform of 1 plus j 2 pi t equal to, we need to find out what is given. The Fourier transform of this function is given as this. Then we need to find out the Fourier transform of 1 by 1 plus j 2 pi t. Okay, this is like a duality property of the Fourier transform. So, what is the duality property? Before going into the problem, we will see what is the duality property of the Fourier transform. See, using duality property of Fourier transform, x of t, when we taking Fourier transform, we will get x of omega. So, then capital X of t, this capital X of t, when we taking Fourier transform, it is nothing but 2 pi into x of minus omega. 2 pi into x of minus omega. So, it is in the angular frequency. When we represent it in the frequency, we will get x of this capital X of t, Fourier transform x of minus f, x of t, x of omega, then x of t, capital X of t, we will get x of minus f. So, don't forget this minus sign. So, what is given in the formula? Fourier transform of this function is equal to this. We need to find out the Fourier transform of 1 by the same thing, instead of f, we need to, they are giving us t with respect to time now, Fourier transform. Then Fourier transform of this function e power minus t u of t is nothing but 1 by 1 plus j 2f. What we need to find a Fourier transform of this with respect to t? What is that? X of minus f. So, x of minus f nothing but we need to change by t, change t into f, and then in place of t to minus f. That is the meaning. Okay, x of minus f. So, instead of t, substitute minus f. Already one minus is outside. So, minus f for t alone. So, then u of minus f, unit step function. So, then what we will get? Minus into minus plus e power f u of minus f. So, answer e power f u of minus f is the right answer. Okay. Here also e power plus f and u of f. This is also wrong. E power minus also wrong. So, e power minus f u of minus f is also wrong. E power f u of minus f, because I am telling you again, substitute t by minus f. Already one minus sign there. We need to u of minus f only. Okay, because x of minus only. For every value we need to, because t by minus f na, t by minus f, then u of t by minus f. Okay, for every place of t we need to change to minus f, t by minus f. This is the concept. Then given that f of s is the one-sided Laplace transform of f of t, the Laplace transform of integral 0 to t f of tau d tau. This is nothing but integration property of the Laplace transform. Right? Integration property of the Laplace transform is nothing but Laplace transform of, we will see, Laplace transform of f of t is nothing but f of s. Then integration 0, this is also based on the properties of the Laplace transform. So, when doing signals and system, we should be very clear about the properties of transforms, all transforms. What is that? Laplace transform, Fourier transform, Z transform. Then only it will be easy to solve this problem by seeing the question itself. No need to take much time. Okay, without knowing the properties of transform, we could not proceed these problems. Okay, then it is the simple integration property of the unilateral. Unilateral means one-sided Laplace transform. One side, what is that? Minus infinity to t. F of tau d tau is nothing but f of s by s plus, this is the general one, 1 by s minus infinity to 0 f of tau d tau. The tau is varies from 0 to t, though, so this term will get 0. So, my integral 0 to t f of tau d tau, we will get f of s by s only. So, f of s by s is the right option. So, 1 by s f of s is the correct answer for this problem. Option B is the right option. We will move on to the next one. The trigonometric Fourier series of an even function of time does not have, see, even function. Even function have only DC term and cosine term. Okay, this is very important. Fourier transform of even function having only DC and cosine terms. Odd function will have sine function, sine terms. Okay, so even function does not have sine terms. Okay, even function does not have sine terms. We'll see the general formula for f of t is given as even function. In general, f of t equal to a naught plus summation n equal to 1 to infinity a n cos n omega t plus b n sin n omega t. A naught is nothing but 1 by t naught integral minus t naught by 2 to t naught by 2 f of t dt. This is the DC term. Okay. Then a n is a cosine term or even term, even function. 2 by t naught minus this is the general function for trigonometric Fourier series. Then 2 by t naught minus 2 integral f of t cos n omega t dt. If it varies from minus t naught by 2 plus t naught by 2 can be written as 2 into 0 to t by 2, t naught by 2. Okay, that is nothing but 2 by t, here 4 by t naught. So for even function, no, will not have cosine terms. So nothing but cosine terms will be 0. Okay. Sorry, very sorry. For even function will not have sine terms. So this will be 0. Then move on to the next one. Given f of t equal to Laplace inverse of 3s plus 1 divided by s cube plus 4s squared plus k minus 3 into s, if limit t tends to infinity f of t equal to 1, then the value of k is. What is given? Limit t tends to one function is f of t function is given, Laplace inverse of this one. Limit, this is nothing but Laplace inverse of f of s. Okay, this is f of s. So limit t tends to infinity f of t equal to 1, we need to find out the value of k. So if it is tends to infinity, it is nothing but final value of theorem of Laplace transform. As I said earlier, we should be very clear about the properties of all transforms. Okay, then only we will solve problems in signals and system and communication system, most of the engineering electronic subject. Okay, mainly on systems related subjects. Okay, then also control system also. Okay. So this is what is the final value theorem of Laplace transform. Limit t tends to infinity. If it is tends to infinity, this is a steady state or final value theorem. In general, what is the final value theorem? Limit t tends to infinity f of t equal to limit s tends to 0 s into f of s. It is given as 1. Okay. What is f of s is given? Then s into limit s tends to 0. Whenever limit t tends to infinity in s domain, limit s tends to 0 s into f of f. Given function is f of s. So just substitute that value. Then in this denominator take s as common, s square plus 4s plus k power k minus 3. Okay, this and this will get cancelled. Then substitute limit s tends to 0. So 3 into 0, 1 in the numerator, then this will get 0, this also 0, then k minus 3 alone equal to 1, which is given in the question. So 1 by k minus 3 equal to 1, 1 equal to, then k minus 3 equal to 1, k equal to 3 plus 1, 4. See here. Okay, k equal to 4. So what is that? Option D, 4 is the right option for this problem. We'll move on to the next one. A 5-point sequence x of n is given as x of minus 3 equal to 1, x of minus 2 equal to 1, x of minus 1 equal to 0, x of 0 equal to 5, x of 1 equal to 1. This is known as 5-point sequence, 5-point given. So minus 3 to 1. So what is given? What we need to find out? Let x of e power j omega denote the discrete time Fourier transform of x of n. X of n is known DFT of x of n, discrete Fourier transform of x of n, x of e power j omega. The value of integral minus pi to pi x of e power j omega into d omega is. We need to find out the value of the given this one. Okay. So first we will write the x of n. X of n, how can we write? See, this one x of n equal to minus 3 to 0 na, this is minus 3, minus 2, minus 1, this is 0, 1. Whenever arrow indicates the position of 0, 0th position, okay. So, minus 3 equal to 1, minus 2 1, minus 1 equal to 0, then x of 0 equal to 5, this one, then x of 1 equal to 1, okay. Okay. So, this is the sequence given in x of m. What we need to find out? First we will find out the x of e power j omega, then we will find out the value for this from this, okay. X of e power j omega is nothing but discrete time Fourier transform of this x of n equal to this one equal to this. So, this is nothing but we need to find out the minus integral pi to pi x, this value into d omega. So, from this taking inverse inverse discrete Fourier transform, what we will get x of n equal, what is the formula? X of n equal to x of e power j omega, when x of n 1 by 2 pi integral minus pi to pi x of e power j omega into e power j omega n d omega. So, now substitute n equal to 0 here. So, x of 0 equal to 1 by 2 pi. This is a general formula, guys. This is a general formula. Then now we need to substitute we will substitute the value n equal to 0. Whenever n equal to 0, here also one n equal to 0. So, e power 0 equal to 1 only. What we will get? 1 by 2 pi x of 0. X of 0 value is nothing but 5 equal to in the right hand side 1 by 2 pi minus pi to pi x of e power j omega d omega. So, what we need to find out in the question, see, minus pi to pi x of e power j omega. So, we need to find out the value for this. So, this will go to that side 5 into 10, 5 into 2 10 pi, 10 pi equal to this value. So, what is the value of minus pi to pi x of e power j omega d omega is nothing but option B 10 pi. Okay. We will move on to the next one. The unit steps response of an system starting from rest is given by c of t equal to 1 minus e power minus 2t for t greater than 0, the transfer function of the system. So, what is given? The unit step response of a system starting from rest c of t is given. We need to find out the transfer function. Transfer function is nothing but h of s. So, whenever it is x of t, this output c of t, this is the h of t. In frequency domain x of s, h of s into c of s, right? This is the given time. What we need to find? Transfer function is nothing but h of s. So, c of s equal to output c of s equal to h of s into x of s. I am writing here. See, c of s is nothing but h of s into x of s. We need to find out the h of s. So, transfer function na. So, h of s is nothing but c of s by x of x. So, c of t is given. C of t is 1 minus e power minus 2t. What is input? Input x of t is nothing but unit step response of a system. So, input is x of t is nothing but u of t. So, u of t, then take Laplace transform x of s equal to 1 by s. Laplace transform of u of t is nothing but 1 by s. Then c of t equal to 1. For 1 is nothing but 1 by s minus 1 by s plus 2, right? For e power minus 2t is nothing but 1 by s plus 2. Then take LCM, s plus 2 minus s, this and this get cancel. So, s 2 divided by s into s plus 2, this is c of s. So, c of s we know and s of s also we know. What we need to find out? H of s. H of s is nothing but c of s by x of s. So, c of s, write c of s value divided by what is x of s? 1 by s. So, 1 by s will go to the numerator into s by 1. This and this will get cancelled. Okay. Then we will get 2 divided by 2 plus s or s plus 2. So, h of s equal to 2 divided by 2 plus s. Option B is the right option. Then we will move on to the next problem. V of t equal to 5 into cos 10 power 6 pi t minus sin 10 cube pi t into sin 10 power 6 pi t represents what? This signal represents the which signal? DSB suppressed carrier signal or AM signal or SSB upper sideband signal or narrowband FM signal. We need to find out the given function is related to DSB or SSB or AM or narrowband FM. We need to find it, okay. So, V of t is given as 5 into this term, okay. 5 into cos 10 power 6 pi t into minus sin A sin B. Sin A sin B is nothing but, this is the basic trigonometric formula. Sin A sin B is nothing but minus half cos of A minus B minus cos of A plus B, okay. This is A and take this is as a B. Greater value taken as A and lesser value taken as B. So, cos of minus half into cos of A minus B, okay. A minus B plus minus cos of A plus B, this and this, adding this, okay. Then multiply by constant inside 5 into cos 10 power 6 pi t minus 5 by 2 into cos 10 power 6 pi t minus 10 cube pi t. This already then minus into minus plus 5 is common to all. So, minus this is also half is common to both, okay, plus 5 by 2 cos of 10 power 6 pi t plus 10 cube pi t. So, this is the carrier signal A cos 2 pi fct. The fc plus fm is nothing but upper sideband. This is lower sideband. So, see AM and FM will have the same thing, okay. So, AM and narrowband FM is same thing. AM and narrowband FM is same thing. What is that? It has carrier signal and upper sideband and lower sideband, both having carrier signal and upper sideband and what is that? Lower sideband signal. So, what are all the given? DSB, it is not DSB. AM and narrowband FM both are given in the option. How can we differentiate from both? What is the difference? Okay, it is not SSB or DSB. It may be AM or narrowband FM. Then how can we differentiate from those? What is the difference between AM and narrowband FM? See, narrowband FM contains negative lower sideband. So this is important. What is the difference between AM and FM? AM and FM having carrier signal, upper sideband and lower sideband. So, whereas AM signal, amplitude modulation signal, has carrier, both carrier signal and LSB and USB both should be positive, okay. Whereas in narrowband FM, carrier, lower sideband and upper sideband, it has negative LSB. So, in this question, in this problem, see, it is carrier, positive upper sideband and negative lower sideband. So, it contains negative lower sideband, whereas AM signal does not contain, okay. Both are positive in case of AM. In case of narrowband FM only, it contains negative LSB. So, the given signal is nothing but narrowband FM signal. So, option D is the right option, okay. Then we will move on to the next problem. If If Laplace transform of f of t equal to f of s, then Laplace transform of f of t minus t equal to, this is also time shifting property of Laplace transform, okay. If f of t minus t is nothing but e power minus st into f of s. If f of t equal to f of s, this is a direct question related to properties of the Laplace transform, which is nothing but time shifting property. If f of t minus t is nothing but e power minus st f of s. So, e power minus st f of s. So, what is that? E power minus st into f of s. Option B is the right option for this problem. Okay, we will end up the video up to this. We will continue the video in our next session. Okay, please subscribe our channel Off Campus and click on the bell icon. If you haven't seen, we have posted many videos under ECE subjects and also engineering mathematics. If you haven't seen those videos still, kindly check with the playlist. Okay, thanks for watching.